Hi everyone. Um, so we had some really bad weather today. Not the amount of snow that we thought we would, but if you look at the calendar, you have some assignments over Unit 2 that are going to be due this weekend. And you did watch the Unit 2 videos in preparation for today's class. So you have that as a starting point. And what I'm going to attempt to do here in this next couple videos is outline a few problems to help you get started. I'm going to follow up with a email that's going to have these examples plus some links to some examples of ALEKS problems that are some of the stuff you're going to be doing in ALEKS over the weekend. So at this point, I do still expect that you will finish the ALEKS homework over Unit 2 and watch the videos in preparation for us to cover Unit 3. When we have class next Tuesday, I plan to cover both Unit 2 and Unit 3 together so that we can keep ourselves on track. Again, with all of the different assignments and all the due dates in this course, it's really, really hard if we miss a day to really just kind of adjust and move everything back a day. I can't really do it like that. So we're going to do the best we can. So the first thing I want to kind of talk you through is what we're going to see, and we'll do a little bit more of this in class, but when you look at a function, it's really important that you identify what the parent function of the graph is. So meaning the parent function, and I'm going to pause real quick and make sure I have the right window so I can write some things down. Okay, I updated this window a little bit, but there's in the first couple pages of notes that you watched over Unit 2, there was a set of functions that you had to learn. So there was x squared, which kind of appears to look like a parabola shape. Here, I'll just, let's list the functions that we need to know. We need to know what x squared looks like. We need to know what x cubed looks like. We need to know what the square root of x looks like. We also need to know what the cube root of x looks like. And I'm trying to think. I think one final one that really you're going to be seeing pretty often in this course would be the absolute value of x. So I'm going to draw what these things look like. There is a process in your notes where we draw those functions and then we study the key points of them. I think if you know what these graphs look like, it's going to be easier for you to get these key points. So we can, so the first one is x squared, and that one takes a U shape. X cubed has, I call this an uphill snake shape, kind of like snakes uphill. Square root has what we would call like a ray or a launch shape to it. Cube root of x has this kind of S shape to it. And then the absolute value, I remember this one because absolute value has the letter V, and the graph kind of resembles a letter V. So you need to know, if I give you a function, what the general graph would look like. Now, once you know what that graph looks like, what we can do then is we can get what's called our key points. So knowing what the parent function is and then being able to get key points is a really, really important piece. So my key points here, on every single one of these graphs, 0, 0, and 1, 1 are going to be key points of this graph. We can see that right here. We're going to have 0, 0. And then again, if we plug that in, 1 squared gives us 1. So that's how we know. So that's going to be a key point of all of these. So you don't really have to guess on those. 0, 0, and 1, 1 are key points of all of these graphs. Now the difference with these is, what's that third key point? Because really, if all of these are on these graphs, you could plot these 2 points and then you really don't know what the graph looks like because you're not really sure what that last key point would be. Now with this first one, with all of these graphs, with the exception of square root, we're going to look over here at the negative side and we're going to think about what happens when x is -1. If you don't remember what it looks like, you could plug -1 in, and -1 squared gives us +1. And we can see that that's how we get that point right there. So these are our key points for this graph, okay? So a really important step for these problems over here, and I'm probably going to break this into 2 videos, one where I go over these key points, and then another one where I kind of walk through a couple of this first example. But let's look at this key point. So that first one was -1, 1. X cubed, if I cube -1, -1 times -1 times -1 gives us -1. We can see we have the 0, 0, 1, 1, and then our third key point is -1, -1. Cube root of x, I'll do the square root one here in a second. Cube root of x, also 0, 0, 1, 1, and -1, -1, because the cube root of -1 is -1. Now, when we come over to this one over here, I can't square root a negative number. That's why we don't have anything on our graph over here. So we can square root the 0. Square root of 0 is 0, right? We can square root 1. Square root of 1 is 1. And then we have to kind of keep continuing until we find another number that we can square root. What would the square root of, let's keep going out. I can't square root 2, can't square root 3, but we can square root 4, and the square root of 4 is 2. And then finally, this absolute value, 0, 0, 1, 1, and then this last one, when the absolute value of -1 is +1, which is how we get that B shape. So you'll actually notice some of these have the same kind of key points, like x squared and absolute value have the same key points, but they kind of have different shapes. Square root or x squared has that U shape. Absolute value has that B shape. Same thing here, x cubed and cube root of x have the same key points, but x cubed kind of has more of this uphill snake shape where it's going to be increasing up really fast, and cube root of x has kind of this S shape where it does increase, but it increases at a little bit of a slower rate. So this is just a basic introduction. You're going to see in the next couple examples that identifying the parent function and getting the key points is a really important first step. I'm not going to be able to do these problems if I can't identify what those key points are.